So basically, in this video, we will try to cover the Jacobian. So first of all, the question is occurring, which is what is Jacobian and why we need to use it. First of all, Jacobian is nothing but a determinant which we have to solve during solving of double integral. So basically, why we are using Jacobian? What is the cause it is occurring in like any kind of let's say integral, double integral. So basically, this is the transformation. Uh, this is not a kind of ideal transformation. I'm just an example basically. So you can see we have to find out dx into dy, which is not equals to dy du into dv. There will be a constant part, and the constant is treated as Jacobian. Like if we are saying x square equals to z, so x dx will be equals to dz by 2. So in that case 2 is the Jacobian. However, we don't need to use the Jacobian during solving of any kind of single integral. Like you, jokes apart. So basically, this is the Jacobian and this is the determinant form of Jacobian. Now we need to solve the Jacobian during solving of any kind of double integral if we are taking any kind of transformation during solving. So now let's talk about a very hard example so that you can solve the example easily. Not easily, it is very hard, I mean very complicated a little bit. So let's solve. Let's go to the question. So basically, before going to the question, I want to say something which is you can visible. I mean, sorry, sorry. Hopefully, it is visible. This is called Jacobian prime, and this is the matrix. I mean, the determinant which we need to solve. If we can't find out J, or finding J is basically difficult, right? So in that case, we can use J prime, and we can use this equation so that we can find out the value of Jacobian, the actual determinant. So let's move to the question. This is the question, and the question is not easy. First we have to plot the graph, then we have to find out the straight lines. It's too much complicated question. So let's start solve it step by step. So basically, let's start it. So first of all, let's draw the graph. You can see it is mentioned in the question we are talking about only xy plane. So we will deal with the first quadrant only. So basically, uh, the graph is you can see 1 comma 0. 1 comma 0 is, let's say, this point. 3 comma 1, let's say 3 comma is this point. I'm just assuming, let's say this is 0 comma 1. Well, now we are talking about 2 comma 2. Let's say 2 comma 2 is this point. Basically this is 2 and this is also 2, so this is 2 comma 2. Now you can see here the parallelogram, right? Now what we can do, if you will go through the strip process, in that case you will see, if we are trying if we are trying to do the strip process, then we have to break the strip. Like if we are talking about horizontal strip, let's say, so this is horizontal strip, this is horizontal strip, let's say, wait a moment, and this strip is moving from this point to this point, and the breaking points are this and this. There will be two breaking points because there is two corners, I mean there are two corners, right? There are two corners. And if we are talking about vertical strip, again there will be two corners. That's why the vertical strip will be breaked into three portions, so it is too much complicated. In that case, we can use Jacobian for solving that. First we have to understand the straight lines. First of all, this straight line is too much easy. This is basically nothing but x plus y equals to 1. From the intersecting point we can easily find out it. Now let's talk about this. This is basically the parallel of x plus y. So this is nothing but x plus y equals to constant. What will be the constant? The constant is let's say this is 3. Let's say constant, let's say this is k. Let's say this is k. this straight line is crossing from this point, and this is nothing but 3 comma 1. Just put x as 3 and put y as 1. You will see k equals to 4. So this is 4, x plus y equals to 4. Now let's talk about this. You can see this is 3 comma 1 and this is nothing but 1 comma 0. This is 0 comma 1. This is 2 comma 2. Hopefully it is visible. Now basically now it is more visible to you. Now basically if we want to find out this straight line and this straight line, we have to use a simple formula which is basically called the slope intersect form or something like that. I have forgotten. However, so basically y minus 1 by x minus 3 is equals to 1 minus 3, sorry for a mistake, 0 minus 1, 1 minus 3. This is y minus 1 by x minus 3. This is minus 1 by, I mean basically half, plus half. 2y minus 2 is equals to x minus 3. This is x minus 2y is equals to 1. This is the straight line. So basically this is x minus 2y is equals to 1, right? This is also x minus 2y equals to any kind of constant. We have to know the constant. So let's put y equals to 2 and x equals to 2. If we are putting y equals to 2 and x equals to 2, then the constant will be minus 2. You can use simple mathematics, simple algebra for finding the let's say the straight line, the equation of the straight line. Now let's solve. So basically you can see here is x plus y. So we have to take a kind of transformation. So basically in that case we will use this transformation. X plus y equals to, let's say u, sorry, x plus y equals to, let's say u, and x minus 2y is equals to, let's say v. Two straight lines are there and we have to take simple transformation. Now you can see here, which is x plus y. X plus y is this straight line and this straight line, right? So basically we can see here x plus y is basically nothing but less than equals to 4, less than equals to 1. You can see x plus y is starting from 1, the slope is 1, and the slope sorry not slope, I mean I'm talking about the intersecting points. The first intersecting point, I mean the c1 is 1 and the c2 is 4. So this is for x plus y. And what about the x minus 2y? You can see the intersecting point is starting from 1 and ending from minus 2. So basically as the minus 2 is basically we know that minus 2 less than 1, so this will be 1 and this will be minus 2. So basically using that thing we can easily say the limits of u. U is basically nothing but less than equals to 4, less than equals to, I mean greater than equals to 1. And what about v? V less than equals to 1 and greater than equals to minus 2. Now let's solve the Jacobian part. You can see the Jacobian, I mean the finding Jacobian, it's too much hard in that case. From the formula we can easily say that the finding Jacobian is too much hard in that case, because we have to differentiate y with respect to u with respect to, so we will going to use, I mean we will be going to use this formula right now. So you have to understood I mean you have to understand, sometimes I make mistakes. However, you have to understand when you need to use Jacobian prime and when you need to use Jacobian. So in that case we need to use Jacobian, otherwise you have to solve for this and this equation for saying that x is equals to u plus v or something like that, and y is equals to u plus v or something like that. Then you can differentiate it with respect to u and v. But it is not easy. I mean it is not easy, means it is easy, but we need to take, I mean we have to take much more time. Otherwise we can easily find a j prime. So let's find out j prime. Basically del u by del x, del u by del y, del v by del x, del v by del y. Now Now another thing which I want to say, when you are using the transformation, then don't put Jacobian prime, put the mod of Jacobian prime, or put the mod of Jacobian. It is another thing which you need to know. Now you can see the derivative of u with respect to x is nothing but 1. I mean j prime is basically 1. This is again 1. You can see from this equation. From this equation you can solve this part, del v by del x, I mean the differentiation of v with respect to x, I mean partial derivative of v with respect to del x, x or however, is basically 1, and with respect to y it's minus 2. Now you have to solve the mod. This is basically minus 2 into 1, which is minus 2, minus 1, which is minus 3. So this is minus 3 and the mod. So the j prime, I mean the mod of j prime is 1. Now wait a moment. Now we can see the integration is this, right? X plus y whole square dx dy. Now we have to replace this with as I have told you that x plus y. Now it is visible. Wait a moment. Now it is visible. So x plus y, as I have told you that integration is this, and we have told you that x plus equals to 2 and x minus 2y equals to v. In maximum cases, if we are talking about straight lines, we have to take in maximum, I'm just talking about natural cases, we have to take x plus equals to u, or x square equals to let's say x square plus y square equals to u, or something like that. Don't need to know, you, it depends on the question, but in maximum cases you will see that you have to take xy equals to v, or xy equals to u, and x plus y equals to u. Just for general assumption I am telling that, so that it can help you, nothing more than that. So basically we have to replace x plus y as u. It will be becoming u square and into mod of Jacobian prime. No, not Jacobian prime, it is Jacobian. We have found out the Jacobian prime. The mod of Jacobian prime is basically 1 by Jacobian. So the Jacobian, the value of Jacobian is nothing but 1 by 3. Be careful about that. Into du dv, and the limits of u is basically, I have told you, from 1 to 4, and the limits of v is basically minus 2 to 1. Now this is basically 1 by 3, so I am taking it out. Now this is v equals to minus 2 to 1. This is u equals to 1 to 4, u square du dv. There is no term about v, so we can easily integrate with respect to dv, and we can easily integrate with respect to du separately. So integration of u square is nothing but u cube by 3 with the limits of 1 to 4, into integration of dv is basically v with the limits of minus 2 to 1. So this is 1 by 3. This is 4 cube minus 1 by 3. This is 1 plus 2, right? So this is basically 3 cancelled out. This is 4 cube, man, this is 64, right? So this is 1, this is 3, this is 63 by 3, which is 21. Again there will be a unit cube, I mean unit and unit cube, sorry. Why? Because again it's a volume integral, because there is an extraordinary function, right? So this is and volume integral, I mean this is a volume integral, that's why we have to use unit cube if we are putting the units. Thank you. This is all for today. In the next video we will try to cover the polar coordinates so that you can relate with double integral, and then the double integral will be ended up. This is all for today. Thank you. Goodbye. If you want to subscribe, then subscribe. If you want to comment, then comment. If you want to like, then like. Goodbye. Goodbye. Goodbye.